to Learning at LASM. My name is Ms. Haley, and today we are exploring our universe with filtered light. I have two light filters, one blue and one red. What do you think will happen when we look through one of these at a deep space object? Let's try. Here we have a planetary nebula known as NGC 2818. Planetary nebulas form when an aging star begins shedding its outer layers. This expanding shell of gas often forms a ring or bubble shape. While these nebulas are unrelated to planets, 240 years ago, German-born British astronomer William Herschel named these deep space objects due to their round planet-like shape. Let's take a look at this nebula with our red filter. What do you predict will happen? The other colors have disappeared. In this image of NGC 2818, the red represents nitrogen. Using our red filter, we can find where there is nitrogen in the planetary nebula. What about our blue filter? What do you predict may happen when we look through it? Let's try. In this image, the blue represents oxygen. Using our blue filter, we can locate where the oxygen is present in NGC 2818. Want to know more about detecting and coloring gases in faraway objects? How do we know that the red is nitrogen and that the blue areas are oxygen? Check back with us at virtual-lasm.org for an update. Now that we have seen what these filters can do, can you help me find out how they work? Let's experiment. Using a black piece of paper, we'll draw two circles. Crayons work best, or some thick colored pencils. First, we will draw two circles on a piece of paper, one red and one blue, and then look through our red filter. Looking through the red filter, what should we see? We see the red circle, and through the blue filter, we see the blue circle. Light filters allow us to block out all colors of light except the one that we want. In this case, the blue only lets blue through, and the red only lets red through. If you do not have black paper at home, you can use white paper with one small trick. Draw your red circle with a pink highlighter, and your blue circle with a blue highlighter. Look through your red filter. What will you see? What about through the blue filter? Did we just break science? Our blue filter should show us things that are blue, and red should show us things that are red. Why doesn't this work on white paper? How many colors make up the color white? All of them. Think about our sun. It's the source of white light. And when a rainbow is made in our sky, we see all of the visible colors. How many colors make up the color black? You got it. Black is the absence of color. Think about the deep abyss of space. In the absence of light, the sky is black. Let's use our red filter to analyze. When we look at pictures drawn on white paper through our red filter, we see the opposite of what we were supposed to observe. This occurs because white paper reflects all colors of light, including red. By looking at our drawing through the red filter, we see the blue circle. This is because the paper is reflecting red, which gets mixed up with the red from our circle, allowing it to disappear. The same occurs with the blue circle on the white paper with the blue filter. So, why doesn't this occur on the black paper? Because black is the absence of color. The black paper does not reflect any color that would interfere with our filters. So we see what we're supposed to. Red with a red filter and blue with a blue filter. You can have fun experimenting with color filters and deep space objects with a few supplies at home. You'll need white and black paper, pink and blue highlighters, blue and red crayons, and some traditional 3D glasses with the red and blue lenses. Then draw with your highlighters on white paper or crayons on black paper and test your filters. Look through only one lens at a time by closing one eye and keeping the other open. Then switch. I hope you all had a blast experimenting with filtered light. Thanks for joining me today, and don't forget to check back at virtual-lasm.org for more fun activities and the science behind the beautiful planetary nebula we viewed today. Bye!